nicotine time. So one of the other milder stimulant type drugs. But this one, pretty simple origin, obviously, comes from tobacco plant, genus Nicotiana. Earliest recorded use, well, I guess archaeological findings have found traces of tobacco plant in structures or whatnot that were from 12,000 years ago. However, recorded history, they say about 6,000 BCE is when the first known use by humans was, but whatever, it's thousands of years. It's, I guess, what was considered a New World crop. This comes from the Americas. I'm always talking about how nobody smokes anymore, but come to find out, I guess we, US, China, Brazil, India, and former Soviet states are still the top consumers. Producers, I can't imagine that much. We're still the top producer, but anyways, the thought is that this alkaloid molecule is a natural insecticide, kind of like cocaine, that the plant makes in order to keep insects from eating it. So, yeah, that's nicotine. There's the structure there. Gets broken down, CYP2A6. So this one actually kind of sticks around for a while, hour and a half, half-life for nicotine in circulation, is converted to cotinine that lasts for much, much longer. Obviously, though, different routes of administration are going to choose the exposure, but this one you really just get oral, right? You either smoke it or you chew it, or yeah. So those that are heavy users of nicotine like to have a saturation level all the time. And that's kind of a challenge with any drug, really. But I guess that was always the anecdote that I heard. You can tell you're addicted to nicotine if you have your first cigarette within half an hour of waking up every day. Do with that what you will. Yeah. But obviously, the inhaled cigarette smoke would have the fastest onset of nicotine. So looking at blood nicotine concentration from cigarettes, you have the highest initial or the shortest latency, if you will, with the other orally administered versions of tobacco having potentially larger, longer concentrations, but it just takes a bit longer for it to set in. Like everything else we've studied so far. So, still fits that pattern. But nicotine actually hits acetylcholine receptors. So I think we just talked briefly about these before. There's acetylcholine receptors, there's nicotinic and muscarinic, right? The muscarinics were named after the muscarine from fly agaric plants or from mushrooms that produce that chemical. Nicotinic acetylcholine receptors were named because they were found to be hit by nicotine, right? But they are acetylcholine receptors similar to GABA in that they have these transmembrane subunits. So this is one subunit here, but one of the 5 of these will fold into a pentamer. Different subunits similar to gamma, alpha, beta, gamma, delta, and then as shown here, assembled into an actual pentamer within the cell membrane. It's an ion channel, again, right? This one, though, is for sodium, calcium into the cell, potassium out of the cell when it's open. Right. And then all of them contain 2 alpha subunits which bind the actual endogenous ligand acetylcholine. Okay? And talk about that's importance in just a bit. But nicotine is an agonist at this receptor. Acetylcholine, again, is its endogenous agonist. Nicotine is an exogenous agonist, but still does activate this ion channel. Functional nicotinic acetylcholine receptors contain at least 2 alpha subunits. And there's a whole range of different combinations of the alphas and betas and all of that kind of stuff. But the only ones that we're interested in really are Alpha 4 beta 2, this is the primary target of nicotine, and alpha 7. All of these both get hit. Well, and then, so in the brain, these two, autonomic ganglia, alpha 3 beta 4, these are the three that we're concerned with. There's plenty of others that get hit. But what's really important for these, taking a step back, the idea of desensitization in these receptors is very important when we're talking about nicotine activity on the body, right? So the way that these receptors work, you have several different states: active, desensitized, and resting. The active state is when the ligand is bound and it's open for business, and you can get calcium, sodium in and potassium out, once again based on their local concentrations inside or outside the cell. But the active state is when you have ligand bound and then it's open. So you can have ion flux across the membrane through this channel. From here, there's an actual conformational shift in the receptor that causes a desensitized state. It's desensitized because it's not allowing for ion flux as well as it is not accepting ligands, right? You still have ligand bound here, but you're closed, okay? That's desensitized. Resting state is when the ligand has been kicked off, but it's still in a closed conformational state. So in these two, you don't have ion flux, only in the active state you do. But this desensitized state is important for understanding nicotine's effect on the physiology, as we'll talk about in just a minute. But, there we go. More importantly is the rate of desensitization, okay? So as I mentioned, alpha 4 beta 2 is the primary target of nicotine, but it's also a fast desensitizing receptor. So this is the first one that's going to shut off after you have ingested nicotine, okay? So it's no longer able to be acted on by nicotine or acetylcholine. Alpha 7 is a slow desensitizing one. So this still can be hit by nicotine after exposure. And again, we'll talk about why that's important in a bit. Alpha 3 beta 4 is another slow desensitizer, but this is in the autonomic neuron and kind of outside of our, the psychotropic effects, but it is still important for the physiology of this drug. So one other note that's important for these receptors is where they are on, so these are choline neurons here, presynapse, postsynapse. Alpha 7s are presynaptic neuron receptors. Alpha 4 beta 2 are postsynaptic terminal membrane, right? So that's very important for how this works. And to take a step back and look at the system here, first of all, a quick aside. I know throughout the semester I kind of bounced between these two different cross sections of brain. Human on the left, rat brain on the right. And I've never made that distinction. But here they are side by side. And here's our reward circuitry, right? So we've got our VTA here and here. And then our nucleus accumbens here and here. Then our PFC here and here. But now we're also adding in tegmental pedunculopontine nucleus, or TPP, here. So, this diagram is a pretty accurate representation of what's going on in the brain in terms of inputs and controls in these areas, right? But when we talk about actual nicotine effect on the brain, I'm not going to use this one. It tends to be misleading, and I'll show that, or when we get into the actual thing in a minute here, why that's important. So the dopamine, right? This dopamine is the central one in this situation. This is our reward circuitry. We should have a projection here to our glutamate out in the PFC. But as you can see, the TPP has acetylcholine that is controlling the GABA and dopamine as well, all right? Lots of layers of control, as I'm sure all of the neuroscience majors and anyone who's had neuroscience in the class knows. There's lots of different layers of control and certain redundancies, okay? But again, Dopamine will turn on this circuit, will be further potentiated by the glutamate on dopamine. It can be controlled by the GABA neuron in VTA, but we'll also see TPP is important for controlling dopamine as well here. So the two basic themes that I want you to remember for nicotine is in terms of the reward pathway. Acute nicotine administration, right, so this is the immediate exposure and exposure for naive animals, is a dopamine independent type of pathway, all right? Rewarding effects of chronic nicotine, so after multiple exposures, is dopamine dependent. Those two things you gotta remember well. Acute is dopamine independent, chronic is dopamine dependent. You can show it in an animal model. So here's our condition place preference exam again. Got a rat or a mouse in here. One side of the chamber is not so comfortable, the other side is comfortable. You can steer that animal to either side based off of where you're giving a reinforcing or a rewarding type of stimulus. Looking at the top row here in the nicotine naive, this is our acute situation. With no pre-treatment, we can force the animal over to the uncomfortable side by giving nicotine. The other side, if we give saline, they get no reward, so they're not interested. If we provide a D1, D2 non-selective antagonist into this system, it doesn't have an effect on the outcome, okay? Dopamine independent. Now, bottom row, chronic nicotine after multiple exposures. No pre-treatment, we see the same thing. You could steer this rodent into the uncomfortable side with nicotine because it's getting some reward there. However, with a non-specific dopamine receptor antagonist on board, it actually cancels this effect, so you have a slight preference for going to the comfortable side, but the idea is it abolishes this effect, meaning the rewarding effects of this of a chronic nicotine situation are dopamine dependent, all right? Acute nicotine exposure is dopamine independent for the reward pathway. Chronic nicotine exposure is dopamine dependent, all right? How this actually works in the brain. So, as I said before, the earlier slide, think of this in terms of the model of structure in the brain, okay? Think of this diagram in terms of function for nicotine in the brain. Again, because if you really look at these, yeah, the more perceptive of students will notice some hypocrisy or some discrepancies between these immediately, all right? It's not so important that these don't match up. This one is showing how dopamine works. This one is showing how the brain is wired, okay? So this figure is for the structure in the brain. This figure is for activity of nicotine in the brain. So, back to the story. When we're talking about acute or immediate exposure to nicotine, what happens here is we see our receptors labeled on the different neurons. So yeah, to get oriented, here's our dopamine neuron in the VTA going out to the nucleus accumbens. We don't have a projection for PFC, but then we have our GABA and our dopamine in the VTA. Here it's listed as PPT, but this is the pedunculopontine, okay? And then the lateral area for the glutamate neuron. But where they are isn't as important as the fact that here we have acute nicotine exposure. All of the nicotinic acetylcholine receptors are going to be hit by the nicotine here. They're still blackened out, so they're active, but alpha-4 beta-2 and alpha-7 are all on, okay? Multiple inputs into this situation, the overall activity is an increase of dopaminergic activity here. Even though you're turning on GABA, which should be turning this off, we're also turning on glutamate, which is turning this on. We also have alpha-4 beta-2 on dopamine, which is turning it on. Overall effect here is that we're increasing the dopaminergic tone in the VTA and then consequently in the nucleus accumbens. This is acute nicotine exposure. All of these acetylcholine receptors are getting turned on. Now, after chronic exposure, as we said, alpha-4 beta-2s are desensitized, so these are off. We're not turning on these anymore. However, we have alpha-7 on the glutamate neuron. Alpha-7 is still sensitized to nicotine. That gets turned on, glutamate gets turned on, it turns on dopamine, and then again here we have an increase in the dopaminergic tone in this area, all right? So, initial nicotine reward in the acute situation is from activation of alpha-4 beta-2, actually from all receptors, but remember alpha-4 beta-2 specifically. This is our fast desensitizing form. This is what's getting hit and turning everything on. Alpha-7 is kind of along for the ride, but because this is already on, its input isn't as profound as it is in chronic nicotine administration. Activation here is from alpha-7, okay? These are desensitized, this is not. Alpha-7 is able to turn on glutamate neuron, which turns on dopamine neuron, activating the reward circuitry, okay? Please just remember those for this. Yeah, how does that sound? I should do that approach. Questions, concerns? Okay, hopefully straightforward. Now, other effects of nicotine are cardiovascular, outside of the reward pathway. Commonly have an increase of blood pressure, increase of heart rate when you ingest nicotine. So in this schematic, we've got our CNS here, right? Our brain, spinal cord. Now our peripheral ganglia, or the paravertebral ganglia here, and then our efferents out to the side. This all is this all, okay? This is just more molecular detail, but we're looking at the same thing here. This is just more detailed anatomy. This is more accurate pharmacologically, if you will, because we're talking about the neurotransmitters and the receptors involved. So what happens here normally is we have the preganglionic sympathetic neuron can release acetylcholine onto the postganglionic sympathetic neuron. This is an alpha-3 beta-4 acetylcholine receptor that we talked about before. Once that's turned on, it will release norepinephrine out onto the heart and blood vessels, causing an increase of blood pressure, an increase of heart rate, as we've seen before. Same thing happens with nicotine on board, all right? Nicotine can activate here, increasing the norepinephrine tone, increasing blood pressure and heart rate, or increasing heart rate and subsequent blood pressure is the way it should be said. But nicotine will also act here, right? Turning on this system, and that's another kind of peripheral response to nicotine ingestion. In terms of the bad sides of things, in 1950, Morton Levine published the first study linking smoking to lung cancer. So in JAMA, he did this study for 12 years and showed essentially smokers are twice as likely to develop lung cancer as non-smoker. And then the increase of cardiovascular disease happens through high blood pressure, cardiac arrhythmias, atherosclerosis, myocardial infarcts, and stroking out due to the fact that there's not just nicotine in there, there's tar in there, carbon monoxide in the smoke, all kinds of other particulates that are really bad. The carbon monoxide can displace oxygen from hemoglobin, causing a person to be hypoxic, and that itself can increase blood pressure outside of the effect of nicotine. But approximately 5 million Americans die every year from nicotine-related illness. Those numbers are going down, but it's still not great. One of the biggest problems here, and yeah, don't worry so much about this slide. This is more addressing that issue. with the cardiovascular injury that you have. So does everybody know you got arteries, you got veins, right? The biggest arteries coming off of the heart, and then every branch point throughout our body, it gets smaller and smaller and smaller, but at the branch point, as you can imagine, as blood is flowing through, once you hit these branch points, that can cause turbulence and also damage to the endothelial lining that would be here, right? Once you damage that lining, you get platelet aggregation, you can have plaque formation. If those plaques kick free, they can cause stroke and all kinds of bad stuff. The development of this revolves around a lot around production of nitrous oxide, and we're not going to get into all of that. Just know that the problem that we have with the cardiovascular system in this situation is due to an elevation of blood pressure, and you can have pathologies that develop just due to the structure of our anatomy. So that's the big thing here. As far as development of dependence goes, smoking every day for a month can lead to nicotine dependence. But this is a really, nicotine is an odd one because, I've always heard anecdotally, nicotine is more addictive than cocaine. Some people say nicotine is the most addictive molecule on the planet. But there's a lot of ifs, ands, or buts with that because certain people develop addictions, well, everybody develops their own addictions differently. So making broad statements about which is the most addictive molecule in that is kind of counterproductive. But back to nicotine, some of the things that fit a dependent / addictive sort of personality, but avoidance of withdrawal is really big with nicotine. And this becomes one of the reinforcing properties, obviously, just due to the fact that the irritability, weight gain, difficulty with concentration, the effects with mood, and then effects with weight gain are some of the biggest problems that people have when trying to quit. Particularly in women, they have more of a problem with weight gain when trying to quit cigarettes, and weight gain after quitting is a strong predictor of relapse. As nicotine can suppress appetite and help increase fat metabolism, and that's, not as good as like performance enhancing drugs do, but there will be a certain amount of higher lipolysis in nicotine users. Back to our DSM-5, tobacco use disorder again is what this is characterized at, but it has some very familiar details to it. Repeated unsuccessful attempts to quit or reduce, reduction or eliminating going to social if you know that people you're going to be hanging out with are not smoking or they don't allow it, you stop going to these sorts of events. Continuing to smoke even though it's bad for your health, and then smoking more than you should, just because you feel like smoking more than you should, even though again it causes harm to your body. These are all signs of definite addiction, at least dependence, right? Factors that we've seen before, your socioeconomic status, surroundings that you grow up in can influence nicotine use and addiction. Genetics, definitely, but this is one, aversive versus rewarding effect. So I'm going to say this just once here and then completely forget about it. This is one of those things, and I don't know how many people I lose when I say those things. Nicotine is a really difficult drug to study because you can show the rewarding effects of nicotine very easily, especially in vivo, when working with animals. However, there is a lot of data, a lot of studies that have shown that this is more of a discriminating molecule or aversive molecule, a punishing molecule. And there's a lot of debate in the field which side of the fence this rests on, because those seem to be very, those are in contention with each other. Those don't make sense that you would have a molecule that gives you a reward as well as a molecule that punishes you. And so they're really still, this is a hotly debated thing. And so we'll leave it at that. It's been shown to be rewarding, it's been shown to be punishing. For our purposes, we just deal with it as a rewarding molecule, just do the in vivo studies I showed. But it is something that should be mentioned because it's a current issue that researchers are dealing with, and they really are trying to understand how this molecule can be both, because it seems like you can't be. But they've definitely shown that there is certain aspects of nicotine use that are more punishing than they are rewarding, okay? And it isn't just the health aspects, it actually has to do with brain biochemistry. I'm gonna leave it at that, okay? Just be aware of that, but for our purposes, again, we'll just talk about turning on the reward pathway, so that's a rewarding feature, but all right, enough hand waving. So in terms of the genetic subtype that predisposes people towards nicotine addiction, CHRNA5A3B4 gene cluster on chromosome 15. So here's our chromosome, here's our gene product here, CHRNA5. The aspartic acid at position 398, and that gene product that is changed to asparagine. Don't need to know the specific mutation, just know CHRNA5 is a mutation in that gene product causes predisposition towards nicotine addiction. Apparently they say that it's like a supercharging type of response, just due to the current, the electrophysiology currents you get from that are higher than other wild type receptors. So the thought is that you get a bigger reward if you have this specific mutation. And people with this mutation not only are more prone to nicotine addiction, they're more prone to becoming heavy smokers. So that's the one mutant type we'll talk about here. As far as treatment for this, NRT, or nicotine replacement therapy, has been used semi-successfully for several decades. The idea is that you put someone on something like a gum, a nasal spray, a patch on your skin, and then you gradually draw down the amount of nicotine in a person. So someone can get their nicotine rewards without having to actually smoke. And then if you stay on the NRT, you keep using gum or spray or whatever with less and less nicotine on it till you finally eventually wean yourself off of it. Tons of problems though. Smokers hate the nasal spray. The gum is unpredictable. I don't know if you know many smokers. I lost track of the number of people that go to see them and they're sitting outside with a cigarette and they're chewing on gum. They got 3 patches on their arm. What the hell are you doing? But that's, a common thing for what that's worth. Some efficacy with the patch. So patch is effective in 20 to 30% of cases, but compared to 10 to 15% of placebo, you really, don't know how good that is, especially because the biggest bottom line is any of these treatments, relapse is almost 100%. So 95% relapse within a year on any of these treatments. So success is pretty poor here. But there are several pharmacological agents that are being used for treating nicotine addiction: bupropion, varenicline, patch shown here. So bupropion, norepinephrine, and dopamine transport inhibitor, so it blocks DAT and NET. Also works as a nicotinic receptor antagonist, all right? Success rate, 20, maybe 30% at a year. Biggest problem though, you have to keep using it. Once people stop taking bupropion, there's a huge relapse problem. And one of the advantages with this medication that they've seen is that though there is a strong correlation of weight gain with abstinent smokers, bupropion seems to alleviate that, just due to the fact that they seem to be getting some, at least minor reward from this drug. And so they no longer look to eat to compensate or to provide that reward system. That's the one thing this has been good with. Varenicline is a little bit better. This is a partial agonist at alpha-4 beta-2, so looking at a dose-response curve, if nicotine provides 100% effect, varenicline would be somewhere down from there as a partial agonist. Studies have shown varenicline is better than bupropion. 12-week study showing 44% of people abstained from smoking on varenicline versus 30% of people on bupropion, and this is a 3-month study, so the weight of that isn't that great. Another study tracked a bit longer and found that about half stayed off versus 40% in a placebo group, but the biggest problem, once again, after you stop the treatment, the number went to half. So you had 23% of the people were abstinent from the varenicline cohort versus 12% on placebo. So again, success rates for these aren't great, but yeah, they are the tools that we have to work with currently. However, 20 years ago, chemists developed vaping or electronic cigarettes as a means to hopefully help people get off of cigarettes. I'm sure everybody here is familiar with these. They come in all kinds of shapes and sizes. Some look just like cigarettes. Some look like these ridiculous machines that are more, well, whatever. But, again, you're all adults. You all make your own money. You can buy whatever you want with your money. But anyways, these are a bunch of different e-cigarette types. And the idea here is that you can deliver nicotine without smoking and without delivering all of the other crazy chemicals from cigarettes that are bad for you. But does it work? So this study took about 400 people, winnowed them down to about 300 people, and then split them into 3 different cohorts, okay? They took 2 different types of vaping pens or vapes, right? One was high nicotine, and that had 7.2 mgs of nicotine per. It'd be rough, like 20 to 30 hits is the estimation for a cigarette. So you get roughly this amount of nicotine per 20 to 30 hits on a vape pen. So they had high nicotine, They did a study over 12 weeks. They split the study in half, all right? For the first 6 weeks, you either get high nicotine vape pen or no nicotine vape pen. Second, the first cohort got the high nicotine, one got a lower nicotine, and one got no nicotine for that second 6-week portion. After those 12 weeks of using, they then stopped and then observed them for the rest of the year to see how well they did, and the results were unsurprising, but yeah, not very good. So these people were roughly pack-a-day smokers. They all smoked about 20 cigarettes a day. That was where they started. As soon as they got to about 2, or when they started the experiment, everybody dropped the amount of cigarettes they smoked daily precipitously. However, as you can see through the actual vaping phase, there's an overall increased trend in the amount of daily cigarettes consumed. And placebo faring the worst, or the no nicotine containing vapes fared the worst. But the biggest thing, really, the biggest take home is after that 12 weeks, for the rest of the year, everybody went back to smoking essentially. And as you can see, they're smoking almost half of what they were before the study commenced. But the idea is that it didn't promote abstinence from smoking cigarettes, at least in this study. Another study showed that comparing e-cigarettes now to NRT, or nicotine replacement, and they were using anything, patch, gum, lozenges, nasal spray, anything they could. And the only thing I really want to point to is that the e-cigarettes had a better outcome after 52 weeks, roughly 80%, or 20%. were abstinent after that time versus 10% on the NRT. So marginal success, if you will. The biggest thing that vaping has over cigarettes is the amount of stuff in the secondhand smoke. Okay, so total nicotine between a cigarette and e-cigarette can be normalized. Roughly 1 milligram of nicotine in a cigarette versus 30 puffs of an e-cigarette. Here you get 1 mg. So the total amount of nicotine you deliver to yourself is the same if you standardize the amount of hits from a vape versus a cigarette. However, the biggest problem comes with the stuff that comes out of the smoker's mouth after they take a hit from a cigarette or a vape. As you can see, the amount of material coming from a cigarette smoke exhale is about an order of magnitude higher with a cigarette compared to a vape pen, right? So this is an issue. However, when it comes to vaping, the nicotine is encased in a gel or a hydrophobic substance. Well, diethylene glycol isn't, but just some, you have to have some medium to embed the nicotine in. That medium has to be combustible in order to produce the vaping, right? Early formulations of vape pens use diethylene glycol. Use propylene glycol, and that can produce diethylene glycol when it is incinerated. This is highly toxic and caused a lot of problems, or the development of vape lung was a big thing. They thought this could be from non-pharmaceutical grade propylene glycol being used, and immediately changed the formulation for this, and now they don't use that anymore. They can use polypropylene glycol, or PEG, for this, which doesn't have as bad of an effect. But that was one of the early findings with vapes, is that there's less of the bad stuff in the exhalant from a vape pen compared to a cigarette, but you still have, there's a new mode of toxicity, if you will, with vape pens, just due to that medium that you're embedding the nicotine in. And that's, the last thing that they found, and we'll get into this more in the next time, comparing the e-cigarette to a conventional cigarette, the size of the material in the exhalant. What they found, the e-cigarettes contain heavy metal nanoparticles, if you will. So this data just shows, size, the diameter of a size coming out. And you can see here there's a lot more at this diameter in an e-cigarette compared to a normal cigarette. The idea is that you're getting these heavy metals in the exhalant from the e-cigarette. And so again, the market has changed because all of the heating elements used to be metal-based. Now they're moving to ceramic-based and other things. It's kind of a cool market study, really, because we see, there's a product that came on the market, and there was some bad stuff associated with it. Formulation, they immediately changed the formulation of that to be more healthy, if you will. And then they changed the actual design of the vaping pen itself to not have the metal come in contact with this, the medium that nicotine is in. Bottom line here is that toxicants are lower in the vaping compared to tobacco smoke, but there's more higher diameter particulate matter in the vapors from heavy metals. Yes, please.
You know anything about third-hand smoke? My ex's mom was a vet, and she said e-vapor smoke settling on bed sheets has been increasing cancer and stuff like that in pets, cats, dogs.
Oh, very interesting.
Sit in those environments and then get that on their fur, lick themselves, and they're definitely heavy metals.
Do I know anything about third-hand smoke? I don't at all. That's a really interesting point, though. I could look into that. That's really interesting. So third-hand smoke would be once you breathe out, and then it gets, on surfaces, pets, whatnot, laying it, getting interesting. No, I don't. But that's the big bottom line here. Trade one good for a bad and create some other bad, or I don't know how to say it, but so that's the difference between cigarettes and e-cigarettes, and that's nicotine. Let me know if you have any questions or issues with the quiz. Hope everybody has a good weekend. See you all next week.